Welcome back. So we're going to be using the point-slope form to write equations in slope-intercept form. And problems in your notes are marked. All right, so example, we're going to find the equation of the straight line that has a slope of 1/3 and passes through the point -18, -3. So we're given the slope and we're given a point. Right? So the x-coordinate is x1, the y-coordinate is y1. We plug these values into the point-slope form, simplify the left side, and just isolate y. Right, so here's the point-slope form. And now we're going to just substitute the -18 for y1. The 1/3 for m. And the -3 for x1. And we want to simplify the negatives. Oops, we're missing, I'm sorry, that's a -18, not 18. So that should be y minus -18. So the two negatives are going to become a plus, so y plus 18 equals 1/3 x plus 3. We're going to use the distributive property and distribute the 1/3 to the x and to the 3. So we have y plus 18 equals 1/3 times x is 1/3 x. And I'm just going to do the multiplication over here just in case you're not sure. 1/3 times 3. All right, well, that would be 3 over 3. Right? Or we could cancel the 3's. But either way, that's just 1. And now we need to solve for y, which means we're going to subtract 18 from both sides. So y is equal to 1/3 x minus 17. So now we've taken it from point-slope form and rewritten it into slope-intercept form. So that's another good thing about point-slope. It's really easy to write the equations into slope-intercept just by distributing your slope and isolating y. Let's do a few more problems together. All right, so here we want to find the equation of the straight line that has a slope of -5/4, and passes through 15/8. Right, so now our first step is we're going to take our point-slope form and we're going to substitute the -5/4 for m and the 8 for y1 and 15 for x1. So I had to put the slope first. So we have y minus 8 equals -5/4 x minus 15. Okay. Right, now we're going to distribute the -5/4 to both terms. Right, so we have and we're rewriting these into slope-intercept form. All right, so we'll distribute the -5/4. Now this one's not going to be such a pretty fraction, but that's okay. Y minus 8 equals, oh, I should probably write that down. Distribute -5/4 to x and 15. So we have y minus 8 equals -5/4 x. All right, so where am I going to do the math? Over here, I guess. So we have -5/4 times -15. Right? There's no simplifying there. That's just going to be -5 times -15 is going to be a positive 75. And then 4 times 1 is 4. So it's going to be 75/4. So we have plus 75/4. Now the only way we can combine the 8 with the 75/4 is to change that to fourths. Right, so if we want 4 to be in the denominator, and technically a integer has 1 in the denominator, it means we'd have to multiply the 1 times 4. Well, if you multiply 1 times 4, you have to multiply 8 times 4. So that would be 32/4. So notice 32/4 and 8 are the exact same thing. Equals -5/4 x plus 75/4. So here I'm just going to put like denominators. We didn't have that step in the other problem. And now we'll just solve for y. All right, so we're going to add 32/4 to both sides. So our equation is going to be y equals -5/4 x plus 107/4. And there we go. There's our equation in slope-intercept form. So you see it's a lot easier to write them in point-slope, but if we need to change it to slope-intercept, we can. Let's do a couple more. All right, so now we got 2 points. We have to find the slope. All right, so we can also use the point-slope form of an equation to write the equation of a line in slope-intercept form. When we only know 2 points on the line, we just have to find the slope first. All right, so use the point-slope form of a line to write the equation of the line that passes through 6, -2, and 4, 8. So we're going to use those points to find the slope. Remember, we take the difference in the y-coordinates over the difference in the x-coordinates to find our slope. So we have 8 minus a -2 over 4 minus 6. So 8 minus a -2, that's going to be the same as 8 plus 2. Then we have 4 minus 6. So that's going to be 10 divided by -2, which is -5. We can use either point. It doesn't matter. Let's use 6 -2. Right? So we have y minus a -2 equals, and we had -5 is our slope, x minus 6. All right, so we're writing it in slope-intercept form. And so we need to simplify those negatives and then distribute the -5. I won't write the steps, I'll just do the steps because I don't have enough space. So we have y plus 2 equals -5 times x minus 6. So we've simplified those negatives. Now we're going to distribute the -5. Y plus 2 equals -5x. -5 times -6 is a positive 30. And now we need to subtract, oops, I didn't mean to hit the extended page, subtract 2 from both sides. All right, so that's going to give us y equals -5x plus 28 as our equation in slope-intercept form. Okay? Now it doesn't matter which point we used. We could have used 4, 8. So let's see if we get the same equation if we use 4, 8. On the next page. Right, so our slope was -5, and now we're going to use 4, 8. Let's see if we get the same equation. So remember, the point-slope form of the equation is y minus y1 equals m times x minus x1. That looks like a 7 out of parentheses. All right, we'll substitute. All right, so this is our m, this is our x1, y1. Right, so we have y minus 8 equals -5x minus 4. We'll distribute the -5. We have y minus 8 equals -5x. -5 times -4 is a positive 20. And now we'll add 8 to both sides. And you can see that we get the very same equation in slope-intercept form. It didn't matter which point we used. Right? There's an infinite number of points we can use on our line to write the equation in point-slope. When we simplify it to slope-intercept, we'll always get the same equation. Okay. Right, here we have another problem. Right, so we want to use the point-slope form to write the equation, and we're going to write it then in slope-intercept form when we're done. Right, so we have our slope. Well, we don't have our slope, but we can find our slope by taking the difference in the y-coordinates over the difference in the x-coordinates. So, and it doesn't matter who's first, just be consistent. So if I'm going to start over here with these 2 points, then this would be x1. So I have to make sure that I line up my points. And now that I've done that, I have no room for my slope. So let's move it down just a little bit. So we have 6 minus 2 divided by -12 minus a -9, which would be 6 minus 2 over -12 plus 9, which is going to be 4. And this would be a -3. So -4 thirds. You can use either point. I'm just going to use negative 12, 6. I won't use both points this time. All right, so we have y minus 6 equals negative 4/3 x minus a negative 12. All right, here I have some space, so I'll write out the steps. So we substitute. Ooh, oh, I hate when that happens. Well, at least it didn't mess up everything. I leaned too close to the board. So we want to substitute. Come on. There we go. Substitute. So I get notes about my disk is getting full, and my computer says it's getting full. I don't know if you see those notes. For x1, y1, and m. All right, that's our first step. Now we want to simplify the negatives. So we have y minus 6 equals negative 4/3 x plus 12. And now we'll distribute. So we have y minus 6 equals negative 4/3 x. If you're not sure, you can just always do the multiplication over here. If you're not sure, on what negative 4/3 times 12 would be, just set it up like that, right? And you can always reduce. Remember, when you reduce, you cross-reduce. So 3 divides into 3 one time, and 3 divides into 12 4 times. That would give us negative 16. If you didn't reduce, you'd get the same answer, because you'd have negative 48 divided by 3, which is also negative 16. So you have y minus 6 equals negative 4/3 x minus 16, and then we'll add 6 to both sides. So we have y is equal to negative 4/3 x minus 10, and that's the equation in slope-intercept form. And there we go. Another one is done. And that's my signal that that's the last of the problems on this podcast. Thanks for watching, and see you in the next podcast. Bye for now.